Okay guys, this is on page 98 in your student journal. Okay guys, we're going to look here at the rational root theorem. This theorem looks very complicated, but it's actually a very nice theorem because it narrows down the possibilities for our zeros or our roots. When I say zeros and roots, we're talking about solutions. And the reason it's called rational is because this works for non-radical roots, roots that are not radicals. What this is saying is that if we're given a polynomial function with integer coefficients, which is what we usually see, integers just means like, -1, 0, 1, etc., then every rational solution of f of x equals 0 is going to have the following form. It's going to go a factor of the constant term divided by a factor of the leading term. And notice that it has to be in descending order for this to work. All right, so what does that mean? Well, come down here. We've got some space. It says find possible rational roots for this function. Rational roots would mean that we're setting this equal to 0 and trying to solve. It's asking us for the possible rational roots. There are some numbers that are not possible answers. On the ACTs, they might ask you, for this problem, is it possible that 5 would be a 0? No, is the answer. They might ask it this way, of the following, which is not a possible 0? And they would have a bunch of things in the list, but 5 would be in the list. 5 is not a possible rational root. It's not a possible 0. And here's why. The only possible rational roots are the factors of this divided by the factors of that. Tell me numbers that are factors of 6. 1, 2, 3, 6. Tell me factors of 2. 1 and 2. So now, any number that is going to be a root, it can only be 1 divided by 1, which is 1. 2 divided by 1, 2. 3 divided by 1, 3. 6 divided by 1, 6. 1 divided by 2, a half. 2 divided by 2, I already have it. 3 divided by 2. And 6 divided by 2 is 3, which I already have. So plus or minus any of these are the only possibilities for rational zeros, for rational roots. 5, no. -3, is that a possible rational 0? Yes. -3/2, is that possible? Yes. Okay? So it's a very nice thing to have. Because if you had this problem on the ACT and they asked you whether 5 is a 0, can you see how you might try to factor this and solve it to see if 5 is the answer? But if you knew the rational root theorem, you would know 5 is not even a possibility. So there's no sense wasting your time checking to see if it's a 0.
So are you just taking the GCF basically? Or
No. I'm looking at the factors of the constant term divided by the factors of this first term. Those are the only possible answers to x if I set it equal to 0.
Okay.
All right, let's come down here now. And this says to find all real zeros of the function f of x equals x cubed plus 10x squared plus 31x plus 30. We're supposed to find all of the zeros. So that means I'm going to set this equal to 0. I look at this to do grouping. Is this going to be possible to be done with grouping? I could take an x squared out of here and I'd be left with x plus 10. Could I take something out of there, though, and be left with x plus 10 to do grouping? No. Grouping is not possible. But they're asking us to find all the real zeros. So I'm going to have to do some work with this. Well, my possible zeros are going to be plus or minus 1, 2, 3, 5, 6, 10, and 30. 15, thank you. Left that one out. I will tell you that it's pretty rare that these higher numbers are zeros. It's usually the smaller ones. So if I want to find all the zeros, and let's say this is on non-calculator part, because I could always type this into my calculator and find the zeros very easily. But if this is non-calculator, I would try 1. If I plug in the number 1, am I going to get 0? Not even probably not. This is all addition. Is it possible for me to get 0? No. Negative 1. Well, I'd have negative 1 plus 10 minus 31. So negative 1 plus 10, that's 9. Minus 31 plus 30, that's not going to give me 0, is it? So 1 and negative 1 are not 0. So let's try 2. I don't even know. That's hard to plug in, so I'm going to use synthetic. Notice my thought process here. I'm trying to just sub in, but 2 is going to give me big numbers, so I'm not going to do that. So I do this, I get 2, 12, 24, 55. Am I going to get 0? Is that going to be a 0? I'm not going to go any further, guys. Some of you waste your time by going further. I can see it right now. I'm going to go ahead and try negative 2. I'm trying to find a 0 here. Sometimes they give you a 0, which is nice, but they did not give us one. So we have to find it. So this is 8, that's negative 16, that's 15, negative 30, great. Why am I saying great? That is a 0, okay? So now this is my constant term, this is my x term, this is my x squared term. So now I have x squared plus 8x plus 15 equals 0. Are there numbers that multiply to be 15 and add to be 8?
Yes.
3 and 5. So these are going to be my zeros.
So once you find one, you just stop.
Once I find one, I keep going to find all of them. It says to find all real zeros. So I found my first one. It was negative 2. And then I got to here, and so then I just kept going to get my zeros. How many zeros should I have? 3. So those are all of our zeros. Those are all of our solutions. Now, guys, remember all of the methods we have here. Let me show you something else we could have done. If this problem had been on the calculator part, look what I did. Look, guys, if this is on the calculator part and I want to find the zeros, I can put it into my calculator. If I look at my table, can you see the zeros? Negative 5, negative 3, negative 2. See how those are my 3 zeros? How do I know I don't need to scroll up and look for other zeros? The degree, right? I'm supposed to have 3 zeros. There they are, right there. Negative 5, negative 3, negative 2. Okay? Questions? Okay, guys, here's a very important thing, too. If we are given 2 zeros, the quadratic function for those 2 zeros is always going to be this. And I'll give you a second to write that down. Given 2 zeros, the quadratic function is, it's always going to be this. X squared minus the sum x plus the product equals 0. That would be the equation. I should really say equation instead of function, but that's okay. This would be the equation that would have the 2 zeros. X x squared minus the sum of the zeros plus the product equals 0. Okay, that's a little bit complicated, but let's come over here on the back. Do you guys have some room somewhere? Okay, find some room somewhere. All right, give me two numbers. Noah, give me two numbers. Any two numbers. Make them kind of small, though.
2 and 7.
Okay, 2 and 7. So here are our zeros then. Our zeros are x equals 2 and x equals 7. We're trying to come up with the equation that has these zeros. One way to do it would be this. If this is my 0, what was the factor? And here's my 0, so what was the factor? So now I would say that would have to equal 0. I multiply it out. X squared, this is negative 7x, negative 2x, that's minus 9x. Negative 2 times negative 7 is positive 14 equals 0. That would be the equation. If we wanted the function, this would be the function. Now, look at this though, guys. This is the function that has these zeros. What's the sum of 2 and 7? What's the product of 2 and 7? See how we could have gone immediately down there? It's x squared minus the sum x plus the product.
That's if we know. So this is if we know the zeros.
If you already know the zeros and you want to find the function, you want to go backwards. Okay?
Can you also use that to just check your work, basically?
Yes, absolutely. That's a great thing to point out. Like if I wanted to come back here, I could totally check that by finding these two's quadratic and then multiplying by that one's factor. All right, guys, now let's go back over to this page. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that radical b is irrational. That means like radical 5, radical 6. Is radical 4 irrational? No, it's rational. What this one says is that if a plus radical b is a 0, then a minus radical b is also a 0. Remember how I mentioned that in the warm-ups? So if 2 plus radical 3 is a 0, what else is? 2 minus radical 3. These are called conjugates. Conjugates must go together. Now, find yourself some space. You don't need to write out these directions. Just listen, and then I'm going to have you come up with some numbers for me. Write a polynomial function, f, of least degree that has a leading coefficient of 1 and has the given zeros. So I'm going to give you some zeros. Let's say that one of our zeros, give me a number, somebody, any number, say it. 4, I heard first. 4 is one of my zeros. The other one I want to be irrational. So I want it to be, let's do 2 plus, give me a number. 3. 2 plus radical 3. So here's a 0, here's a 0. And then, so they're telling me that these two are zeros. But what else must be a 0? 2 minus radical 3 must be a 0. Think of what we did back here to come up with the equation. I had to multiply it all out. But remember the shorter way to do it? Let's take these two and let's come up with the quadratic that has these for the solution. The quadratic. What do I look for? The sum and the product. What's the sum of these two? If I added these two, what do I get? 4. The product, I do the first is 4. The outers are 2 radical 3, negative. The inners are positive 2 radical 3. What's going to happen with outers and inners? Cancel. What's radical 3 times radical 3? Minus 3. So my product is 1. So can somebody tell me what the quadratic is that would have those solutions?
X, like
factor or
The factor, the quadratic factor. Somebody's saying it. X squared what? Then what? Plus 1. Good. If I had this quadratic set equal to 0 and I solved it, I would get these two solutions. I'm going to do it very quick over here for you. X squared minus 4x plus 1 equals 0. X squared minus 4x equals negative 1. Take half and square it. That's 4. Add 4 over here. This is x minus 2 quantity squared. This is 3. Take the square root of both sides. X minus 2 equals plus or minus radical 3. Add 2. Do you see what I'm saying? This, I know that I went really fast, but I'm just showing you quickly how if I were to solve this, I would get that back, those two answers. Now, so this is one of my factors. What's the factor that would have this for the 0? X minus 4, right? So this would be the factored form of what would give me these zeros. So if I'm looking for the polynomial function, I got to multiply this all out. That's x cubed, that's negative 4x squared, that's plus 1x, that's negative 4x squared, that's plus 16x, that's minus 4. So my function is going to be x cubed minus 8x squared plus 17x minus 4. You're only going to have a couple like that, but that's your thought process there. If they give us a nice answer, I know it's just x minus that, and then I can go. If I have numbers like this, go. All right, you guys think you can do this? No, that's not very confident. I have faith in you. I think you can do it. Friday. Any questions? Let me just give you two easy numbers. Just think about this. What if we say x equals 5 and x equals 4? Can you quickly come up with the function that would have those zeros? I hear the pins dropping, so some people have it. Halima, do you have it?
Is it x squared plus 9x plus 20? Or is it minus 9x?
Well, let's see. I'm going to check your answer. Is it right, guys?
I think it's minus 9x.
Well, let's look. So I put these in here. So based on what you told me, the zeros would be negative 5 and negative 4. Are those the zeros you wanted? No, you wanted positive 5 and positive 4. So what are you saying we should change? Minus 9x. Let's see if that works. So if I come in here and change this to subtraction, now I look at my zeros. Did that work? Are those the zeros I wanted, 4 and 5? Yes.
So
Okay.
I see this, but like, how do you know whether it's going to be negative or positive?
How do we know, guys? It's always x squared minus the sum x plus the product. Okay. We're going to stop there. Good job. I know that was a lot to think about.